The James Webb Space Telescope, one of the most expensive and challenging space observatories to construct, has already produced groundbreaking observations and conclusions since its launch. Its major goal is to examine the atmospheres of exoplanets in order to look for evidence of extraterrestrial life. The telescope uses infrared technology to identify planets that are passing in front of stars. At that time, ground-based telescopes employ the radial velocity method to calculate the planet's mass. Think of a far-flung, mysterious place that has long aroused the curiosity of both scientists and the general people. A world that was formerly considered to be a planet that was later demoted, sparking much discussion and controversy. It's called Pluto. But today, thanks to the state-of-the-art capabilities of the James Webb Space Telescope, we are finally getting a closer look at this interesting celestial object. Researchers have already produced astonishing discoveries that have astounded them. What mysteries does Pluto possess? You may wonder how it could possibly impact us. Perhaps most crucially, would these groundbreaking discoveries be sufficient to restore Pluto's planet status? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. Who discovered Pluto? The story of the smallest planet. Pluto, the smallest planet in our solar system, has a fascinating history. From its discovery in 1930 to its demotion from a planet to a dwarf planet in 2006, Pluto has been the subject of much scientific study and debate. Let's explore the story of Pluto, including its discovery, composition, and the controversy over its classification. Pluto was discovered on February 18, 1930 by American astronomer Clyde Tombaugh. Tombaugh was working at the Lowell Observatory in Flagstaff, Arizona, when he made the discovery. He had been tasked with finding a ninth planet in our solar system, as astronomers had observed irregularities in the orbits of Neptune and Uranus that suggested the presence of another planet. Tombaugh used a device called a blink comparator, which allowed him to compare two photographic plates taken in the same area of the sky at different times. By carefully analyzing the images, Tombaugh was able to identify a faint object that had moved slightly between the two exposures. Further observations confirmed that this object was indeed a planet, which Tombaugh named Pluto. Composition of Pluto. Pluto is a small icy world with a diameter of about 2,377 kilometers or 1,476 miles, just two-thirds the size of Earth's moon. It is composed mainly of rock and ice, with the surface covered in frozen nitrogen, methane, and carbon monoxide. Its atmosphere is mostly nitrogen with traces of methane and carbon monoxide. Pluto's moon, Charon, is almost half the size of Pluto itself and is believed to have formed in a giant impact with Pluto early in its history. Pluto has four other small moons: Nix, Hydra, Kerberos, and Styx. Demotion from a planet to a dwarf planet. In 2006, the International Astronomical Union (IAU) redefined what it means to be a planet, which resulted in Pluto's reclassification as a dwarf planet. The IAU decided to be considered a planet, a celestial object must meet three criteria. It must orbit the Sun, it must be spherical in shape, and it must have cleared its orbit of other debris. Pluto meets the first two criteria, but not the third. Its orbit overlaps with the orbit of Neptune, and it shares its orbit with a number of other objects in the Kuiper Belt, a region of space beyond Neptune that is home to many small icy worlds. As a result, Pluto was no longer considered a full-fledged planet, but was classified as a dwarf planet, along with other objects in the Kuiper Belt. The exploration. Pluto continues to captivate scientists even though it is no longer considered a planet, because it can capture images of distant objects. The James Webb Space Telescope is currently all the rage. Many people have asked if it is possible to use the telescope to study Pluto, and the answer is an absolute yes. The JWST just captured a remarkably crisp image of Neptune, which has generated a lot of excitement. The image taken with a near-infrared camera shows Neptune's magnificent rings and weak dust bands, which appear as fuzzy particles between the brighter ice-dominated rings, along with methane ice clouds that appear as sparkling streaks and spots. The image also displays the light band encircling the equator. The image also shows 7 of Neptune's 14 known moons, including Triton, the largest and brightest. Without a doubt, the JWST's superb imaging capabilities will allow it to take stunning images of Pluto that will further our knowledge of the planetoid. Pluto is up to no good, and the James Webb Space Telescope is investigating. Scientists have noticed that Pluto's atmosphere is disappearing, although they are unsure of the explanation. The dwarf planet's atmosphere, which is primarily nitrogen-based, is similar to Earth's. But unlike Earth, Pluto's atmosphere is supported by the vapor pressure of the ice that covers its surface. Therefore, if the ice on Pluto warms, it might significantly change the density of the atmosphere. The New Horizons mission was a space exploration program launched by NASA in 2006. with the goal of studying the dwarf planet Pluto and its moons. After a 9-year journey, the spacecraft arrived at Pluto in July 2015, becoming the first spacecraft to visit the distant world. During its flyby of Pluto, the New Horizons spacecraft took detailed measurements and images of the planet's surface, atmosphere, and moons. It revealed that Pluto is a complex and dynamic world with a variety of geological features, including mountains, glaciers, and icy plains. The mission also discovered new moons and provided insight into the origins and evolution of the Pluto system. Since its encounter with Pluto, the New Horizons mission has continued to explore the outer reaches of the solar system, studying other objects in the Kuiper Belt, the region of space beyond the orbit of Neptune. The mission has provided valuable information about the early history of the solar system and the formation of the planetary bodies. Overall, the New Horizons mission has significantly expanded our understanding of Pluto, and the outer solar system has opened up new avenues for future exploration and discovery. Tombo Regio. The Tombo Regio, a heart-shaped area of Pluto's surface, is one of the many intriguing characteristics of the odd planets that have not yet been fully explored. This well-known site is covered in carbon monoxide ice and has a cone-shaped structure, giving it the appearance of a large ice cream scoop. During a flyby of Pluto, the New Horizons probe created this heart-shaped area. It has a surface area of 1 million miles and is even bigger than the human heart. It is made up of nitrogen glaciers of nitrogen. Pluto's heart also controls its actions because the left ventricle, also known as Sputnik Planitia, caused the planet to turn so that its moon Charon was facing the opposite way. A true polar wander is a phenomenon where the planetary body alters its spin axis as a result of the significant geologic events. Pluto has many tricks up its sleeve, and having dunes on its surface is one of them. In contrast to the sand dunes on Earth, these are made of frozen methane ice grains that have been shaped by wind gusts. Sand dunes are more prevalent than you might think, so don't be fooled. On Earth, Mars, Venus, Titan, and the moon Saturn, and even Comet 67P have been found. Given their immaculate state, Pluto's dunes are assumed to have formed quite lately, probably within the last 500,000 years or even more recently. Pluto offers a fascinating paradox in this regard. Although billions of years old, Pluto's surface features and polygonal shapes indicate a recent active geological system. The most likely explanation for this activity is ice overturning by thermal convection. Scientists are also taking into account the likelihood that the dwarf planet Pluto contains active volcanoes in addition to the startling discovery of a sizable liquid ocean on the planet. It is likely that a frozen ocean exists between Pluto's icy surface, which has slowly expanded and contracted over time to generate these features. This is suggested by the enormous faults that rip through Pluto's glacial surface. Scientists believe that new faults could be forming on Pluto's surface right now if the ocean continues to freeze. Scientists speculate that the berth now may have ignited on fire. Long-held theory among astronomers was that the planet's original underground sea slowly formed over millions of years due to radioactive decay. Recently found discoveries, however, have challenged that idea. Examining images of Pluto provided by the New Horizons spacecraft, scientists searched for clues about the planet's creation. They found that Pluto's surface features, such as mountains and valleys, could provide information on the planet's genesis. The researchers studied these distinctive surface characteristics and then investigated various scenarios for planet formation using computer models. Scientists discovered that if Pluto had started off cold and then inside thawed, it would have contracted and left visible signs of compression fractures. However, the team speculated that Pluto may have had a brief, violent beginning that gave way to an early ocean, because they only observed extensional traits. But how did Pluto generate the heat required for such a spark? The two possibilities considered by the researchers were that the proto-dwarf planet either received heat from the nuclear disintegration or was struck by debris and melted. They discovered that the latter possibility was more likely. These findings suggested that Pluto must have formed swiftly. However, that rapid procedure could have taken up to 30,000 years in the grand scheme of things, which would have been a mere blip on the universe's timeline.